Okay, so welcome to today in finintro we are going to do annuities. And so you've seen stuff like this before, 1, 2, 3, 4, 5, and we've done this with mixed streams, but we have yet to do this where all the payments look the same. When all the payments look the same, say this is $1,000, and this is $1,000, and this is $1,000, and this is $1,000, and this is $1,000, then we refer to this as an annuity. It means that, it comes from an old phrase that you would get paid once a year, or so you get paid once a season, or whatever it is. So you're here, we're going to say that, hey, look, we're going to receive positive, right? These are all positive. We are going to invest. So these are all going to be negative, 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 negative. We are going to invest $1,000 a year, every year for the next 5 years. Now, first of all, there's two types of annuities. There are ordinary annuities, ordinary annuities, and there are annuities due. Okay? If it's an ordinary annuity, it means that you get paid at the end of the first year. At the end. That's an ordinary annuity. Annuity due means you get paid at the beginning of the first year. And so this BEG and this END may look familiar, and you got to make sure when you get to your calculator that you have, here they are, let me highlight them for you, BEG and END, that you have this in end mode. Okay, I just switched it to begin mode. Here I'm going to switch it to end mode. And you can see on your calculator that it may have a little END on it. Okay, make sure you are in END. For the purposes of my class, you're always going to be in END unless I specifically say you have an annuity due or I tell you to switch to BEG. Okay, so that's all that means, that we're going to be doing ordinary annuities. All right, now this can look a lot like the one we've already done. So let's do the future value of this thing. If I deposit $1,000 a year every year, what's it going to look like at the end of 5 years? Well, at the end of 5 years, we've got to do the same thing we did before with our other mixed streams. I've got to look for the future value, which I know is the present value, 1,000, 1 plus, and let's do this at 9%, just for whatever, 0.09 to the. Now, the first thing you're going to do is think that you should do this over 5 years, but it's not 5 years. It's compounding. Let me switch colors. You're compounding 1, 2, 3, 4 years. So we're going to say that we are compounding 5 minus 1. Time period 5, time period 1. From 1 to 5. And the difference between 5 and 1 is obviously 4. We're going to do the same thing with the next one. 1,000, 1 plus 0.09 to the 5 minus 2. And so on. And so on. 1,000. 1 plus 0.09, 5 minus 3. And don't you guys wish I had better handwriting? 1,000, 1 plus 0.09 to the 5 minus 4, which is 1. And then the same thing with this 1,000. This 1,000 is in the same time period, so it is going to be 1,000, 1.09 to the 5 minus 5, which is equal to 0. This whole thing turns into 1, so all we end up with is this 1,000 here. Okay, I add these up, and it turns into whatever it turns into, the total sum at point period 5, and then that would be my future value. Okay. When they're all the same, we can actually calculate the future value, which is not necessarily the case for the mixed streams. Remember when we had the mixed streams, we had 4,000 and 5,000 and 300 or whatever it was, and we couldn't really, or maybe we didn't discuss this, but you can't really calculate those out into the future. We have to do the whole net present value thing and then shoot it forward. It gets a little complex. But when they're all the same, I can do some very special things with my financial calculator. So let's go play with it. First, you'll notice up here on my financial calculator that I don't have anything saved into memory yet. Okay, so let's do our cheat sheet. Let me just scroll down just a little bit so I can do a cheat sheet over here on the side. Future value, present value, future value equals, N equals, my interest rate equals, and today we're going to introduce PMT. So on yours, you should see this PMT button. Okay, we've done N, we've done interest per year or interest, present value and future value. Now we're going to talk about payment. All right, so from this scenario, what are we looking for? We're looking for future value. So I don't know what my future value is. I'll put a big question mark right there. What is my present value? This is a little tricky. The first thing you're going to say is it's $1,000, but that's not completely true because I'm going to begin at time 0. Let me erase this BEG so we don't get confused here. Okay, I'm going to begin here at time 0, and at time 0, how much money do I have? How much money have I invested? I haven't invested anything, so my present value is 0. That's a very important distinction. We don't actually put money in until the end of the first year, and then the end of the second year, and so on. Okay? So what's my N? What are the total number of years here? 1, 2, 3, 4, 5. Easy. 5. And what is my I? Well, we've said earlier that it was 9%, and it's going to be up here somewhere. There's my 9%. So let's just do this at 9%. 9%. And here comes payment. So before we would have, ignoring this, we would have 1, 2, 3 out of 4, and we could solve for future value. Now we're going to look at what the payment's going to do. If the payments are all the same, let's see what that payment's going to do. So this is going to be 1,000. Okay, so let's see what that looks like. Present value is 0, and I put that into my present value. N is 5. 5 is N. 9 is my percentage, and my payment is 1,000. Oops, 1,000 goes into payment. Now I've just realized that I'm on payments per year for 12, so I need to go back. I need to do this. I wonder if there's a way to reset this calculator. Whoops, 1 payment per year, and now I'm back to payments per year per 1. I need to see if there's a way to set that so it's the same. Anyway, so I've got my 5N, my 9%, my 0 present value because I started with 0, and I've got my $1,000 payments every year. When I hit future value, I get negative. Actually, I should have done this with a negative 1. Let me go back and do it. 1,000 negative payment. Calculate future value, 5,984. So this guy, let me go back and erase that. I'm getting really good at erasing. So this is $5,984.71, which is the same as what we would have gotten here, 5,984.71. And that is how we do future value of annuities. A good example, a good practice problem would be to look at, say, a retirement account. Okay, let's pretend that you open a Roth IRA. And I'll talk about Roth IRAs way later in this class. But we create our cheat sheet, future value equals whatever, present value, N, I, and my payment. And if I max out my Roth IRA, it allows me to make contributions of $5,500 per year after tax. So I'm going to make a $5,500 contribution. Where do I put that? Well, it's my contribution and I'm making it per year. I'm going to put it down here. Payment $5,500. And it's going to be negative because it's coming out of my pocket and going into an investment account. So it comes, here am I. I'm a happy dude. I'm a very happy guy, and I'm going to make a lot of money in the future. Yay! And my money comes out of my pocket and into my investment, into my Roth IRA. So it's negative for me, and it goes into there. Okay, so let's just pretend a 10% interest rate. All right, and that's about what the S&P 500 does, depending on who you ask and what the time period is. S&P 500 can go as high as 12%. So let's just do 10% for now, because you're going to dump the whole thing into the S&P 500. And you guys are college students, so you're like 22, and you've got a good 30 years before retirement, which is what's 22 plus 30 equals 22 plus 30 equals 52. Okay, so even then you could calculate, you could compound this for more periods. And my present value is going to be 0 because you guys are college students right now. Your present value is probably really close to 0. And so let's work this out. All right, I'm going to clear all, start with nothing up there, 1 payment per year. All right, $5,500 is my payment. I'm starting from the bottom and I'm going up on this case for no real reason. 10 is my interest rate. 30 is my N. My present value is 0. And let's find out how much money you would have at retirement if, shortly after graduation, you were to deposit $5,500 a year into your Roth IRA. $904,717. Double dollar signs. That's a lot of money. So, you could there's another really quick question you could ask. Well, how much money did you actually put in? And this is just extra. So 5,500 times 30 years means that you only put in 165,000 and you ended up with 904,717. That's not bad. Anyway, I hope you like these. You can do these some more. A good practice problem would be to run these again and do them per month or per quarter or something like that. Get some great practice and enjoy.